So the next problem is insert, delete, and get random at O1 of at the worst time complexity of big O of 1. So we need to implement the randomized set class, and the randomized set initializes the randomized set object. Inserts val, removes the val, get random, random number. So need to implement this. This is more like a software engineering concept involved here, and there is first hash table and designing concepts. So let's implement the same, and there's not much explanation needed here. So let's just jump to the code directly. It's called insert, delete, get random at time complexity of big O of 1. So now, yeah, so let's so write the Python code class randomized set, and we have our init function, which is the constructor function self of data map. Self makes sure that it's inside this class, accessible by other functions in this class. Data map, we're initializing the data map. This is a mapping of data with the index. You'll see later. This is just the data, it's a list. This is a hash map concept we're using. This is just a list. So let's implement the insert function. It will take self, obviously, and val has to be int, and it needs to return a bool. So if now we only insert the val. So if it is in, let's just say var in self of data map, do not insert it, return false. Can't insert it. Otherwise, self dot data map of var equals length of self dot data. So the key is the value itself, and the value is the size of the, or the index of that particular value. So self dot data dot append of val. So append val, return true. Let's implement remove function. Remove to take the self, and val should be int. It also returns a bool. If not, val in self dot data map. Well, why we're checking data map and not data? Well, because this. So remember that the whole concept is about big O of 1. So the insert, we're doing it quickly by checking if val is in data map. So it will be in key. If it has been inserted, just quickly returning false. So this is big O of 1. So here also we're doing the checking big O of 1 thanks to this hash map. So if it is in data of map, if it's not in data of map, return false. Otherwise, proceed with the removing. So what's the position of this value that we're trying to remove? So that's why we are storing the positions in the data map. And so now self dot data map of self dot data of -1. This is the last index. So last, so whatever, so we're just doing swapping here. Okay, so whatever is the last index of the our list here will now be occupied by the value, the position of this value. So uh, so so basically what we're doing is if let's just say that so this is the data map, and so we have the list, right? So we have the list, and whatever is the last value in this list, last value. So the number in this dictionary which has this last value will now be val position. So that's what's happening here. So basically, that's what's exactly happening. And if is just a second. Yeah, so the data map, um, when you're trying to do this, so in this data map, so which is here, so data map is here. So you're here. Yeah. So through the swapping, we are just taking this. So you understand more as we go forward here. So self dot data val position. So that we're swapping with self dot data last with so self dot data last with self dot data val position. So yeah, remember that this is like swapping. Okay, like we're just doing swapping here, and at the end just do self dot data map dot pop of value. So because the dictionary, you can just use pop of value to remove that. It's a hash map, and for the other thing, just do pop because we have successfully put it at the last position. So that's that, and finally, just need to implement get random, and we'll just turn int. So return random. We leave the system pick its own choice of the random number out of the list, and that's what it will do, and it will return the random number.